Hello, so this is going to be a video on taking the derivative of arccotangent of x equals y. It falls in line with all the previous ones we've done, and it is actually the last one in this inverse trigonometric function derivative series. So I'm just going to start off like I always do. Up here in the top left, I just wrote arccotangent of x equals y. Because these are inverses, that means that cotangent of y is equal to x. If you need a little bit better explanation, you can just look up inverse function properties, or you can look at a couple of my previous videos where I probably explained it a little bit more. But I'm just going to use implicit differentiation to take the derivative of both sides of cotangent y equals x right here. And so that's just going to be d over dx. I'm just writing the operators right now. Cotangent of y equals d over dx of x. Okay, and then the derivative of cotangent of y is negative cosecant of y with this squared. Okay, and then that times dy over dx because we are using the chain rule here. All right, and then this is going to just be equal to 1 because the derivative of x is 1. And then what we're going to do is we want to isolate dy over dx. So I'm going to say dy over dx, and I'm going to actually divide both sides of this by negative cosecant squared of y. So that will give me 1 over negative cosecant squared of y. Okay, and then what I'm going to say is I want to write this negative cosecant squared of y in terms of x. And so the first thing you want to do is look over here at your Pythagorean identity, and I want to find a way that I can somehow manage to make this equal cosecant squared of y, some shape or form. And what you're going to do is divide every term in this identity by sine squared, or sine squared of y, right? So this first term, we're just going to have 1. And then here we're going to have plus cosine squared of y over sine squared of y is cotangent squared of y. And then 1 over sine squared of y is just going to be cosecant squared of y. And of course, I can input this cosecant squared of y right here. And since that is equal to 1 plus cotangent squared of y, I can easily just put that in there. So I'm going to do that right now. I'm going to just say dy over dx equals 1 over negative, and then I'm going to say 1 plus cotangent squared of y, but we are not quite in terms of x just yet. So I'm going to look back up here. Cotangent of y we see is equal to x. It was what we started from. So if cotangent of y equals x, then cotangent squared of y will be x squared. So I'm going to rewrite this again, and I'm just going to say, and use another color, I'll say dy over dx, make that a little bit of a better d, over dx is equal to 1 over, really, I should write it like this, negative, because this is how it's commonly seen in textbooks. So negative 1 over 1 plus x squared. Or you may see it x squared plus 1, same thing. But keep a note that this negative is right here. That's important. I could have just wrote it as like negative like this. Doesn't matter. I just moved it out just to make it a little bit neater. But anyways, here's the graph of arccotangent of x equals y down here in the bottom left corner, and you can see it will always be negative. And as you can see over here with this derivative we have, this will always be true because no matter what x is, it's squared, so it's always going to be positive, and this negative will always make this whole thing negative. And so you can kind of see where that comes from and see why that makes sense, as this is always negative. So this, you can see, works.